we are starting 5.5 today. Hi. No. Okay. 5.5 today, performing function operations. Okay. Want you to, this will be in your student journal, page 145. Okay. Just going to take a look at that, read through it. It's on page 145. It's also right there. Zoom in a bit. You guys, you're going to see in this lesson, we're going to spend 2 days on it. I have 1 day back there, so tomorrow we'll spend a second day on 5.5. Just because the notation's fairly new to you, I realize you've seen f of x before and g of x. However, what we're going to be doing in this lesson is we're going to deal with function operations, meaning combining functions using addition, subtraction, multiplication, and division. And part of the weird thing about it is just understanding the notation. I really think this is pretty evident. Add function f to function g, and you get a new function. I think this is not as clear. That looks different. Okay? But they mean the same thing. All right? F plus g of x means f of x plus g of x. They're the same thing. It just means add the two functions together. So if you had the function f of x equals 5x and g of x equals x plus 2, you say 5x plus x is 6x plus 2. That's all you're doing. You're just adding the two functions up. You're combining like terms. Okay? F of x minus g of x, or f minus g of x equals f of x minus g of x. Same thing. 5x minus x plus 2. The key thing to remember there is you would have to distribute the negative sign. Okay, so make sure, especially when subtracting, you put that back function in parentheses. Okay, so you'd have 5x minus x, which is 4x, and then that minus 2. F of g of x means f of x times g of x, and now you're just multiplying the two. So 5x squared plus 10x. And same thing with division. F divided by g of x is f of x over g of x. Don't let the little fraction here make you scared all of a sudden. You're like, oh, a fraction. Okay, and you freak out. Nothing wrong with that. Yeah, just divide. You cannot cancel x's here, right? Tell your neighbor why you cannot cancel any x's. Okay, now usually two answers come up here. Let's see if we get the correct answer on the first try. Who thinks they know the correct answer? Matt? By the entire bottom, which means? Aaron? Yeah, you've got to divide with the 2. So the big problem is the 2. All right? That's all coupled there. It's put together. It's held together. It's a bond. They rode in the same car. Okay? You can't just leave one behind. It'd be like going to the store with your friend and then taking off. Not very cool. Okay?
But it is possible.
Yes? Holy shnikes. What'd you say? 5x squared? Over x minus 2? Is that what you said? You could. It would make it more complex. You just leave it like that. Yeah. Yeah. No, it didn't come from anywhere. She was just making up a problem. That thing that we just had, she just made up a problem. That doesn't exist. Okay. All right. The domains of the sum and differences and products and quotients consist of x values that are domains of both function f of both f and g. Additionally, the domain of the quotient does not include x values for which g of x is equal to 0. Holy cow. We'll talk about that when we start talking about domains. That's just like a, oh, by the way, at the end here. Okay? Start talking about domains. Okay? So, here's what we're going to do. We're going to work through some of these together in our extra practice. Go ahead and turn your page there to page 146. Okay? Yep, that's good to hear. What I'd like you to do is give number 1 a go. Stay organized with your work, otherwise you're going to run out of room. You may even want to use a separate sheet of paper. All right. G, this is fun. All right. F plus g of x. All right, ladies and gentlemen. Okay, when I'm putting together roots, it's important to note that we have to have the same root. So it's the same index. We're doing the cubed root. You have to have the same thing on the inside. So you're counting right now. You're counting how many cubed root of x's you have. Here I have negative 1/2 cubed root of x's. Here I have 9/2 cubed root of x's. And so since I have this, I'm counting the same item, I can combine my coefficients. Negative 1/2 plus 9/2 is 8/2. Cubed root of x's, which is 4 cubed root of x's. All right. That is the sum of them. Now we got to plug in 1,000, right? So when we plug in our 1,000, our negative 1,000, that ends up giving me 4 times negative 40. Very good? Yep, haven't got there yet. But we will. Okay. Any questions up to there? I can't get it to focus. Yeah, when we evaluate it for x. Okay, so the domain. The domain. As we're looking at the domain of this, it's a cubed root function. A cubed root function looks like, anyone know? You know, a cube looks like this. That's a cube.
Oh yeah, it looks like it's that flipped.
It's that flipped. Right. Okay, so your cubed root function goes to the side. It does some wavy thing like that. Okay, or it could be upside down of that. Okay, it keeps going upward forever. It keeps going outward forever. Therefore, if it keeps going outward forever, the domain is all real numbers. So if you want to put your cool little R, you can. Domain is all reals. All realsies. Okay. Any questions there? Woohoo. All right. Tell your neighbor what you got for the subtraction piece. Okay, I'm going to just put on my work for the subtraction piece here. I've already got it done. That way you don't have to wait for me. There, we got it. Checking our work. How many got it? Any questions? Okay, very good. I want you to take a look at number 2. Give number 2 a go. Actually, I want you to finish up through 4 right now. 2 through 4. Number 2. First part, the sum. The sum, negative 4x squared plus 3x plus 8. All real numbers is our domain. We do f plus g of negative 1. We get 1. How many got it? Okay. If you have questions, make sure you're asking as I come around there. And then f minus g of x. Remember to distribute that negative sign in. So it becomes negative 6x plus 3x squared. So you end up with 2x squared minus 9x plus 8. All real numbers. Okay, it's a quadratic. It continues outward forever there. And 19 is what you get when you plug in that negative 1. Okay. All right. Questions? All right, should be working on 3 and 4. All right, number 3. Check it out. Number 3, f of x plus g of x is your x cubed plus 2x squared plus 21, all real numbers. When you plug in the 2, you get 37. And number 3, f minus g of x is equal to 7x cubed minus 2x squared plus 3. All real numbers, my domain. You get 51 when you plug it in. You've got to think about what your graph looks like. It's a cubic function. Okay, a cubic function does this. Thank you. Oh, thank you. A cubic function does that, meaning it's extending outward in directions forever. So your domain is all real numbers. Okay, yeah, or another way to think about it, is there a value for x that does not yield a solution? So can you find a value where you would not get a solution? So if you put 1,000 in, you get a solution out. If you put negative 1,000 in, you'll get a solution out. If you put 0 in, you'll get a solution out. Okay, therefore the domain is all real numbers. Okay. All right. Number 4, I'm going to put that one up so you can see what it is. Number 4, you get, when you add, you get 2 and the 4th root of x minus 1. So 2 times 4th root of x minus 1. X greater than or equal to 0. And you get 1 as your value there. So your domain is x is greater than or equal to 0 on this one. Okay? So you've got to think of a 4th root. A 4th root does this. It starts here and goes out like that. And therefore, wherever it starts, whatever my h value is inside with x, so in this case 0, that's the vertex or the starting point. That's why it's greater than or equal to 0. And then when I'm subtracting, you get 8 times the 4th root of x all plus 3. Once again, it starts at 0 because there's nothing being added to the x in there. So x is greater than or equal to 0. When we put 1 in, we get 11. Does that make sense, Walsh? Understand? Okay. All right. You guys, your assignment tonight is to finish 5 through 8. Zach, did you have a question? Okay. Finish 5 through 8 on that page, please.